All right, so 8.1, the law of sines. Because y'all didn't have notes, right? There weren't any. I don't think I left you any notes. Okay. I was like, I don't want to do this if you've already done it, but probably a good refresher either way. So the law of sines, specifically, it says, if any triangle ABC, and those are just the letters that we're going to use to denote the triangle to keep it easy. It doesn't have to be ABC, but obviously typically that's what we use with the triangle. With angles A, B, and C, and opposite sides little a, little b, and little c. So angles will always be capital letters, side lengths will always be lowercase letters, respectively. The following is true. And so we have, it's going to be the same formula. One is just going to be it flipped. But basically the sine of A, so the sine of the angle A over the side length A is equal to the sine of angle B over side length B is equal to the sine of C, the angle C over side length C. So that's one way that we can write this formula. So when we have like fractions equal to fractions, I can flip the entire thing, and so the other option would be just taking everything and flipping it. So A over the sine of A equals B over the sine of B equals C over the sine of C. Making sure I submitted a sentence. There we go. Gosh. And so this is just a way that we can basically solve a triangle out. I'm going to tell you law of sines in terms of the actual like solving of the triangle is harder than the law of the law of cosines that we'll do. We probably will start that Wednesday, TBD though. It's harder than that, but the math of the law of cosines is harder. Like this formula itself is pretty easy, but determining like what triangles we have and stuff are harder on this one. So from geometry, perhaps you remember that we have different ways to solve triangles. We have things like side, 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 angle, side, angle, side, angle, side. I don't know. I can't remember all of them. I never remember. I think there's like an angle, angle, side one. I don't know. Anyways, so as far as actually solving triangles of the angle, angle, side, and angle, side, angle case, each of these produces one triangle. And you're probably thinking, how in the world can I ever have a situation other than just one? Well, it's based on the information that you're given. So obviously, if you see a triangle explicitly drawn for you, right, that's only one triangle. But if they just give you some side lengths and some angles, that may or may not be the case, because obviously some side lengths can produce like multiple triangles and stuff like that. And we can have different triangles that have a side length of side 18, picked a random number, but the other sides that dictates what they are. So it can make different like quantities of triangles and stuff. But if we have the angle, angle, side or angle, side, angle case, then we only will have one triangle. We hope and pray that that's the situation we get when we do these problems, because we know for a fact it's one triangle. However, Cash, did you have Mrs. Marshall for geometry?
No, I did not.
Okay. So, when I had Miss Marshall for geometry, she had told us at one point that side-side angle did not exist. And as far as geometry goes, that is true. But now it does exist, and that's where the law of sines comes into play. And so if we have the side-side angle case, this can produce no triangle, one triangle, or two triangles. No triangle, wonderful. One triangle, still easy. Two triangles where it gets a little bit more difficult. I don't often put a two triangle problem like where you have to solve it on a quiz or a test because it takes so long. But sometimes you just have to tell me, like, based on the information given, which one you have. And we're getting ready to go over how we would determine how many we have here. So we're going to write a little bit, and then we're going to make, like, a big table.
Can I get a refresher on what the angle and the sine stuff is? Just, like, a quick one.
Yeah, well, basically that's the information that they're giving you to produce a triangle. So, like, you probably would have had something like, this is why I don't teach geometry. So, like, angle, side would be, they would give you, like, this angle and this angle, and then this side length. Yeah. So angle, side. So basically if you set it up on a triangle, it would go around in like whatever order you're reading it off in. And then if it was angle, side, angle, then this would be this. So angle, side, angle would be the information that you're given. So it's basically like whatever pieces of the triangle that they give you, if you drew a triangle and you put just those pieces on there, what order does it fall in? And that's how you like would dictate it. So side angle then, which we're getting ready to draw several of these, but basically what they give you is they'll give you, I want to make sure I'm about to use the same sides I'm going to in here. So they'll give you this angle here, and thus that side, and then this side here. Now, obviously, this is really like an angle and then a side, the order that I'm putting it. We just can't write it that way. I can't write angle, side. I can write side, angle. Read it, look at it. Don't say it, but look at it backwards.
Oh.
So that's why we always write side, angle, but this one's kind of, you can still read it backwards, side, angle, that way. But when you draw it and you look at it, it's going to look like an angle and then two sides side by side, basically. So in this case has to be drawn in this way. So the pieces that they give you, the angle has to be in the bottom left corner. Well, let me put it this way. Doesn't have to be in the bottom left corner. Your life will be much easier if you do it this way because all of our little charts and stuff that we're about to draw that will help you will be drawn this way. And then this side, and then the side that goes with that angle is opposite of it. And like I said, we'll see a lot more of this because the primary purpose of this section is to teach you side, angle. But in the event that you have the other situation, it automatically produces one triangle. So the first thing that I typically do is I'll try to look and see what I have, and it'll probably be easier if I talk about this going through, but oftentimes I will draw a triangle, even if I end up having this no triangle situation. Just because I draw a triangle doesn't mean I'm saying it existed. I was just doing that as a visual for myself. So, but as we go through the cases, I'll kind of go back and explain a little bit better of how this all comes together. So, possible triangles. For the side angle case, So like I said, I'm going to write a little bit, and then we're basically going to make a big kind of like chart here under it. So consider a triangle in which you are given side A, side B, and angle A. So essentially, it's just what I gave you up here in this little picture. By fixing, meaning keeping it set, side B and angle A, we can stretch the possible position for side A to determine the number of triangles that will be formed. So there's one little formula here that sometimes I give later, sometimes I give now, so I'm going to go ahead and do it now. Let's try to focus this in real quick. So note, H is equal to B sine of A. Now, the other thing that I'm going to point out is that you won't always be given side A, side B, and angle A. We could be given side A, side B, and angle B. I could be given side A, side C, and angle C, right? I can be given different pieces of information. I'm just doing this one time generically. One year I went and I wrote out all the possible options on the board, and it took forever. And I don't think that they cared, and I don't think that it helped them. So I've kind of just changed like how I word it and how I explain it, and they found that to be pretty helpful. So this formula here, H equals B sine of A, you're probably like, where in the world did you get H from? Well, H is going to go down in our table, which is what's going to help us determine how many triangles I have. But B here, in case I don't have side A, side B, and angle A, side B is the side without the given angle. All right, so they gave me angle A, so it can't be side A because that goes with that angle, so it has to be side B. So it's basically the one that doesn't have its buddy with it. And then obviously sine of, it has to be whatever the given angle is. And I only need this for the side-side angle case. I have people that start trying to use this for the other situations, and it doesn't work because that's not what the formula is for. So anyways, so now we're going to do a little table. Basically, we're going to have three things going across, but the left side of the table is just going to have one, and then the right side's going to have two. So we're going to have a situation where A is obtuse, so whatever our angle is obtuse. And then the other option we're going to have is that A is acute. I don't really know if that's probably not big enough. So I'm going to have two things over here, and then I'm going to end up with four over here in this box. So, do we remember what an obtuse angle is? Yep, greater than 90 degrees. What about acute? Yep, less than 90 degrees. Obviously, if it's equal to 90 degrees, it's a right triangle, and we wouldn't be doing this. We would just be using Pythagorean theorem and or our just general trig functions to solve them. So I'm going to draw out here a couple things, and then I'm going to write under them. So the first one, I'm going to draw like this. I'm going to attempt to draw them as obtuse an obtuse angle here. It may or may not be perfect, so just recognize that. If I can hold on to this. All right, so these are all assuming that they have given us side A, side B, and angle A. And so this is going to be angle A down here. These are both side B. And so side A is what is going to kind of be our determining factor here, okay? So basically in one situation, I'm going to have side A be kind of short. In this other situation, it actually comes over and touches. So these are both side A. So have you ever seen, well, like a pendulum? So basically we have something like a fixed point up here, and then down this way, obviously we have something hanging off of it, and somebody at the door?
Yeah, sure.
Oh, I guess somehow the door's locked. We did.
Is it okay if I do number 9 on the back since there's not enough space? I don't feel like I have enough space here.
You should have more than enough space there. That's the problem, you're working the opposite way.
Okay.
All right, so anyways, so if we do that, we have basically like we pull the string back and right, it swings through. So essentially I'm gonna, on the paper, attempt to show that. So if I took this side length and I swung it through, notice it never intersects down here on this one. And so that situation would be that side A is less than or equal to side B. If they're equal, it will not intersect either. Okay? If A is less than or equal to B, it never ever comes down here to get to this side, so there is no triangle. So this doesn't actually form a triangle here with the given information. Now this one down here, if I swing this through, it does hit there. And so in this situation, A is greater than B, and so I have one triangle. So those ones are nice and easy. So if it's not, I'm already forgetting, angle, side, angle, or angle, angle, side, we hope that the angle is obtuse because that's our next easiest thing, because it either produces no triangle or one triangle. It's pretty quick to figure that out. We're looking at, is the side with the known angle less than or equal or greater than the side that doesn't have an angle with it? So depending on what information I'm given, little a is right now is the one that has the angle with it. Little b doesn't have anything with it, so it's always the one with the angle compared to the one without. So that'll be kind of like your trick to help you remember that one. And I'll go back over this again when we go into examples tomorrow. All right, over here we're going to have 4 options. I'm going to work one at a time on these ones, though, just so that we don't get confused since there's 4 of them. So I've got my side going across here. Now, these are cute, so I'm going to draw them. I mean, it doesn't have to be anything perfect or anything. But I tried to draw these ones so that they looked a little bit obtuse, at least a little bit greater than 90. Obviously, it can't be, like, too excessively greater than 90, or it's not going to even, like, it's not going to work. Because we have to have 180 degrees in our triangle, so it can't be too crazy, but they can get pretty big sometimes. All right, so this is still angle A, side B. Those things are always fixed. So now, if side A is little, meaning it's short, and it's not long enough to go through like that. When I swing this around, okay, then it never, notice, intersects the bottom. Now, this is where H comes into play. So H is the height of our triangle. So if you think back to, I don't remember when this starts. I know it would happen in geometry, but when you're finding like the area of a triangle, we have 1/2 base times height. So H is essentially our height. This is how we're finding the height given the information. So H is going to be this dotted line here that I'm putting on. And so in this situation, if H is greater than A, we have no triangle. So again, we like that scenario. It means I don't have to do anything other than show what H is equal to and show that whatever that H value is greater than the side length that with the given angle. I like that situation. The next one, let's set it up again. Oh, I made that one really big. So I've got angle A, side B. But this time, A is going to be basically right here. Now, it's looking like it's a right triangle. That may or may not be the case. It could be, well, actually, in this case, it has to end up being. We would not have known it was a right triangle to begin with. Okay, but it basically ends up having to be one. Then, this is A. But this value here is also, just like in the previous one, is also H. So if H is equal to A, then I have one triangle. So again, I like that scenario. It's easy. I still have to solve the triangle and write all the pieces out as to what they are. But there's only one triangle. I like that. Now over here on this one, still setting it up the same way, angle A, side B. Now this one's going to be an interesting situation. So depending on what A is, it's going to swing through, hold on, I made this too long. Depending on what it is, what ends up happening is that this comes and it swings through. And so little a is here, but little a also ends up being here. And then we would have our H coming down on that one. So when we end up with this situation, we have H is less than A is less than B. So it's H compared to the side with the given angle and then to the side that doesn't have an angle with it. And so if this happens, we have two triangles. This is the situation where we get sad. This is the harder one. Now, just so that you get a little bit of a heads up, when we solve these triangles, it is two separate distinct triangles. One of them is the big triangle. The second one is this little triangle in here. So that would be triangle 2. Let's see if I can do this. So this would be triangle 2. The big triangle is triangle 1. Okay, so this whole piece. The big triangle is triangle 1. So the whole thing is 1. And then the second triangle is that itty bitty piece in the corner. Now, the second triangle is relatively easy to actually solve for, but it just requires a lot more work, and there's more things that you have to remember for that process. Over here, if you can twist the button on the lock, so it's like up and down, I think, or opposite of whatever it is. Yeah, now it'll pop open. Thanks. So this is angle A, side B again.
Let me see.
Yeah, that's fine. So in this case, it just hits, and it's going to be hard to see, but basically it would not go back through. My picture's not great with this one, but it would not go back through here. So H is here. Now, in this one, I like to just draw the H, but we don't actually need to find H with this one, because all I really care about is A and B in this one. So if A is greater than or equal to B, then I have one triangle. So I basically have two scenarios for acute angles where I can get one triangle. And so Traylon and I would not be trying to write this down at the moment because this is a huge table that goes with stuff above it. So I would just wait and go back just so that you don't have to, because you end up having to do it again anyways. So this is basically producing one triangle here. Now, my chain of how I go about solving these things, okay? So I look, and I've got this side-side angle case, okay? I know that I've got two sides, and I have an angle that goes with one of those sides, so that tells me right away I have side-side angle. The next thing I'm going to do before I do anything else is I'm going to look at that angle and say, is it acute or obtuse? Okay, because like I said, it can't be right or we wouldn't be using this. So I'm looking at, okay, acute, obtuse, which situation do I have? If I have obtuse, I don't even care about this. I look over here, I look and say, okay, is the side length that goes with the angle less than or equal to the other side, or is it greater than the other side? And then I can determine how many triangles I have. If it's no triangle, I'm done, as long as you write that reason. So what I would need to see for an answer for a no triangle is don't just write no triangle because that doesn't show me that you know why. You would need to say A is less than or equal to B. Okay, or write the numbers that go with those respective sides because obviously we'll have actual numbers, not just letters. If it's one triangle, you're going to show that A is greater than B, and then you're going to go down and you're going to show like solving it out. Okay, so you'll basically list out all your angles. You'll do like angle A, angle B, angle C, and then side A, side B, side C. Obviously, you're given 3 pieces to start with, so you'll just have to fill in the rest. When we have the angle, side angle, and angle, angle, side, which obviously isn't this, it's really nice when we're solving because we can automatically find that third angle really quickly by just doing 180 minus the other two, but that's obviously not this situation. So anyways, but let's say it wasn't obtuse and it was acute instead. My first thing I'm going to do before I go do this extra math to find H is I'm going to see, okay, is the side that goes with that angle or with the given angle, is it greater than or equal to the other side? Because if it is, I don't need to find H. I just know that I have one triangle and I can proceed. However, if that's not the case, if A is less than B or, whatever the situation is, then what I can do is I go back and find H. So we use the side without the given angle times the sine of whatever angle they gave us, and I find H. Now, this is the other thing, and you may want to note this somewhere. For H, go to 1 decimal place past. Whatever the side lengths are. So I will tell you when we're doing these things to always round to the nearest whole number, it makes things easy. When I say that, I mean that in respect to the side lengths and the angles. Okay, now if they give you information unrounded, or if it's like to a decimal, we have to leave it. Or it's going to cause our answer to be different. So like there's one of the problems that they go out to 2 decimal places on everything. And so when that happens, I'm putting that information in as it is. So if I found H, I would need to go to 3 decimal places. We always want to go one past, because sometimes if we round H, it will end up giving us the wrong situation here. Okay, so at that point, once I have found H, I'm looking at H compared to A. I'm saying, okay, is H greater than A, or whatever the side length with the given angle is. If it's greater than, I write no triangle and I just show my reason. So having the math for H and then showing that H is greater than whatever that side length is sufficient work for that. So no triangle problems. There's not a whole lot of work to show, just very basic. If H is equal to A, I'm going to be able to see that in your math, and then we would solve out the one triangle. If H is less than A, and A is less than B, then we have 2 triangles here. And at that point, we would solve. Big triangle is always the first triangle that gets solved, and then that little triangle is the second one. And basically, we do that by subtracting one of the angles from the other one. And so this angle goes from being essentially, it doesn't always happen this way, but most of the time it goes from being an acute angle over here to when it gets moved over here, which this would be angle B, it ends up being very obtuse. And then this angle that was potentially obtuse up here, or at least it was pretty big, it goes to be really, really tiny, as you can kind of see in the way that this is drawn here. And so, you can just set it right there. So that would be those situations. So obviously, a lot of information here. There's a couple area formulas that I'm going to give you as well really quick. And then from there, we will be done for today, and then we'll do examples tomorrow. So for y'all that were taking the test, I'll post the video of these notes, and then y'all just need to make sure you do them tonight, or you're going to be thoroughly confused tomorrow. All right, so area of a triangle, and as I briefly mentioned earlier, obviously we know the area of a triangle to be 1/2 base times height. Well, if we don't necessarily have 1/2 base times height, like as direct information given to us, we don't really know how to find the area of a triangle any other way, right? If they don't give you a base and a height, we can't really solve the area until now. So this would be A equals 1/2, and there's 3 different area formulas just depending on what information you're given. BC sine A, which what you will end up noticing is this is 1/2, a base value, and then C sine A would be an option for H, which we could find depending on what information they had given us, up here, essentially. And when that happens, then that would be our height value. So this still is 1/2 base times height. It just doesn't look like it. Okay? So, anyways, you don't need to know that. I'm just giving you information. A equals 1/2 AB sine C, or A equals 1/2 AC sine B. So those are 3 different area formulas. Basically, all this is saying is if you're given 2 side lengths and an angle that doesn't go with it, with either of those things, you basically just take everything and multiply it together. Really all it's telling you. All you really need to know is one of the formulas, and you should be able to use the other ones based on that. But anyways, there will be one more area formula in 8.2 that we'll get for another way to find the area of a triangle that looks very different than this. When we do law of cosines, it'll go with that. Just to give you a heads up, on the quiz and the test, so after 8.2 we'll do a quiz, and then I have to see what else of chapter 8 we're doing, because sometimes that's all I get to, so we'll see where we get. But on the quiz and the test, I check formulas for you, because I would really hate for you to go through and solve all of these problems with the wrong formula or something like that. So I'll check the area formula. So if you write all three, I'll check all three. If you just write one, I just check one. However, it works. I'll check the law of sines formula for you, which is up here. When we get law of cosines, again, it'll have several different ways that it can be written. I would check all of them or just one of them, however you write it. And there's a manipulation of it as well to help us solve something else. I would check that. So I would start memorizing these formulas like now. I would say that at least tomorrow and maybe into Wednesday we'll be working on this section. Thursday, a couple of you are taking the SAT, so we're not doing anything. So Friday, we'll really get into 8.2. So I would say at the earliest, next Wednesday, we'll have a quiz, just for pacing. Now, I do not check this table for you. So I would also recommend that you start memorizing this table, because if you don't and you wait till the night before, you're going to be confused. Now, the more problems that we do, which I do several examples for you, I don't give you a ton to do on your own that are like required, because quite frankly, if you can do a couple, you should be able to do a ton of them. But also they take a long time. I don't want to give you, 2 hours worth of homework. That's just crazy. Those of you that aren't taking the SAT, Thursday will probably be like work time that you can work on it. So if you are taking the SAT, you will have other time on Wednesday for sure to work as well. But yeah, anyways, unless ACSI needs to be in my room, then I may have to teach something and then we'll adjust the schedule, but that's fine. But yeah, anyways, any questions on that? All right. Then we are done. Just a few minutes left.